on to a different tack now. So we have Dr. Bilal Kaddouh from Mechanical Engineering Department, who's going to talk to us about aerial robotics, where innovation takes flight.
Well, thank you very much. Thank you for inviting me to give this talk. I think this event has been amazing. Today, I'll be going through what aerial robotics are and mainly exploring how aerial robotics technology is reshaping infrastructure, agriculture, and emergency response. So we're going to be looking at what people are doing, what I've done before, and what we're doing at AUB. So first of all, what are aerial robots? As you can see, there is a big range in front of you to choose from, ranging from a handheld, very small drone up to a relatively large multi-rotor. In general, an aerial robot is effectively a flying aircraft with no pilot on board that's being flown by a computer with the ability to compute and to make decisions on itself in order to achieve a certain mission or to achieve a certain goal. Everything from drones, UAVs, UASs, these are all examples of aerial robots. Now, these can go from biologically inspired aerial robots, things like a bird, a butterfly, mechanically flying, or the more common ones that we see in different missions and different environments, things like a fixed wing delivering blood units for stranded areas and remote areas, multi-rotors collecting remote sensing data, delivering certain solutions in agriculture, or even 3D printing a new component or a new action or activity that goes into the environment, so modifying the environment. Now, modifying the environment can take different shapes, so whether you have robotic arms carrying stuff around, or whether you are diving into the sea collecting water samples for different applications, or just simply delivering a package like DHL does. If you're doing remote sensing, there are plenty of different sensors that are used on drones. When you're flying, you have a different view. And that view provides you with the ability to collect data that you are unable to collect otherwise. And for that, there is a wide range of sensors ranging from typical RGB cameras, so these are just the color cameras like you have in your phone, to thermal cameras, to multispectral cameras, to even LiDARs. LiDARs are fascinating things. These are similar to radars. They emit lasers and create a point cloud. That point cloud gives us a large 3D model of the world around us. We're going to see an example in a second. Now, all these sensors can be installed either on multi-rotor platforms or fixed-wing platforms. So aerial robotics is not just multi-rotors and things that fly vertically. No, this includes everything that can fly and has a computer on board and is not manned. So how are we reshaping infrastructure? So we mentioned LiDARs before. These allow us to create these beautiful maps of the environment. Any surveying application these days is relying and using drones extensively. There is no construction project, at least outside Lebanon, in Europe, and in the US, that is not using a drone as part of their initial surveys, or even later surveys for progression, for work progression, and monitoring the construction. These will allow us to create something called a digital elevation map, which is effectively a map that gives us a 3D model of the environment, which is then meshed to create a beautiful 3D model of the environment that allow us to either design something that we want to install, or make sure that whatever we design actually fits within the environment in our 3D model. Now, the ability to create that 3D model also allows us to have a digital twin. So Industry 4.0 is all looking at BIM models and creating a digital twin that effectively allow us to monitor the physical world in a simulated digital model. And anything that we change in the real world will also change in the digital model. So if we wanted to make any improvement or conduct any monitoring, we are able to do it in that digital world. So drones allow us to keep on collecting that data and updating that digital model. Obviously, creating typical maps and automosaic maps, GIS maps, is extremely high resolution compared to typical use of satellite imagery. And monitoring construction work now looks something like this. You can monitor the progress of your workers, you can monitor the usability of the equipment, and you can identify any issues during construction because you have that different viewpoint. Now, this is what is being used now. There is no innovation in there, it's just a beautiful technology that we're using. But when we're looking at how we're reshaping infrastructure, we're looking at doing something more. One of the issues that we face in road infrastructures, it's potholes. These are usually formed because you usually have a small crack in the road, water gets in, and then you have a pothole. To prevent that from happening, one way is to use a system that seals those cracks before they turn into potholes. So at the University of Leeds, we've developed a 3D printing drone that prints with asphalt. We developed tracks so that it can drive on the road. We developed the system that melts the asphalt and detects the cracks and allows the printer to fill in these cracks, as well as effectively flying into place. Now, you'll be asking about, well, how do we block the road? Well, we thought about it. We haven't implemented it. That's probably an FYP for next year, but we thought about flying cones. So you have a fleet of UAVs effectively flying into place, blocking the area that they need to fix, and using the onboard bitumen melting plant, if you want, which is a 3D printing system that allows them to effectively find these cracks. In the UK, we have these banners. So if you wanted to block the road, you just have to digitally write it on the banner, and then cars would move away. So the drone would fly into place, locate the cracks, and we'll see in a second where it reorients its position to find the coordinates of where the crack is, so that the nozzle can be moved into place, and then it starts melting the bitumen and filling these cracks up. Now, obviously, these cracks are typically longer than the 10-centimeter working area of the printer. This is why the drone can be printing while moving, and the nozzle would be moving around in order to maintain the position over the crack. And in this way, we've sealed the crack, we can take off, and we have avoided a major defect in the road. Now, when we talk about roads, we also talk about bridges. There are two types of bridges. The first one we're going to look at is metal bridges. This is a horrible case of a bridge where it's very rusty, but if we wanted to assess the level of rust and the level of deterioration within that bridge, we cannot just do it using cameras and remote sensing. We need to get in there and test it, measure how bad that bridge is. So in order to do that, and to avoid having people dangling from ropes and getting underneath within a effectively harsh environment, we have developed a magnetic robot. Now, how do we use that magnetic robot? We get a drone to deliver it into place. So to do so, the drone would use a thermal camera in order to find where the bridge is. You can see how it's clearly identified due to the difference in material and heat capacitance. It flies underneath, uses its sensors in order to approach the bottom of the bridge, and then has a passive compliant arm, which allows it to deliver that magnetic robot into place. And that robot would drive around, collect all the data, while the drone, so it's cute to see it driving around. It collects all the data about the thrust impact, and the drone will be creating a 3D model of the bridge where all the information will be overlaid. So you end up with a full 3D model of a bridge with all the information about the deterioration there and then for you to use and conduct your assessment. If you have a structural engineer or civil engineer in the audience, they will jump and say, not all bridges are metal. And yes, that's true, they're not all metal. We have a lot of concrete bridges. And in order to be able to inspect these bridges, again, because of working at height and because of all the risks, we have developed a system that effectively takes that small robot, no longer magnetic, and use a robotic arm to deliver it onto the bridge pier cap. This little robot will then go around, inspect the area, and if there is an issue that it can fix using a foam spraying or any sealant spraying, then it will do it. Otherwise, we will have an information for major repair to be called in. Now, that's a little taster from on what system can be used in infrastructure inspection and maintenance. Now we're looking more at agriculture and environment. And this is where our work at AUB comes in significantly. The major problem that we're looking at is overuse of pesticides and overuse of nutrients and fertilizers. We are destroying our soil, we're destroying our planet, we're destroying the environment that we're living in order to increase production of crops, and that's an issue. We still need the crops, we still need the food that we're producing, but we want to do it in a sustainable and environmentally friendly way. Now, to be able to avoid that overuse, we want to be surgical with our use. So if there is an issue, we want to be able to detect it and pinpoint it and only use the required solution for that infected or defective area within our crop yield. To do so, there are a number of ways. One way is to use multispectral imaging, which effectively takes images at different light spectrums. So image at blue, image at green, orange, red, yellow, violet, and so on. This is different than full hyperspectral, where you have a full image of all the spectrum continuously. We just select the few that are relevant, as well as having a thermal footage of the area. And we try to combine this information together in order to understand the state of the crop and the state of the vegetation. Now, the standard work is looking at something called NDVI. I'll go into it in a second. But if we have a dead leaf, then the reflectance of all the rays would be the same. If we have a stressed leaf, the wavelength for green and the near-infrared would be slightly higher than the blue and red. Whereas if everything is okay, we have a very high near-infrared reflection and a relatively higher green reflection compared to blue and red. So now, by just looking at light that is visible and non-visible, we are able to identify which of these areas is problematic and which is healthy. So if you look, we have greenery in here. So we have blue based on this index. And if we don't have any greenery, we have effectively red. So we created a map where we can identify issues, and we can also identify them based on tall plants and short plants. So there is another index that we can use in order to look at taller plants versus shorter plants. Now, again, more indices. So not only looking at the state of the plant, we can also look at the state of the moisture content in the plant and the state of the water content in the area. So we have water indices, vegetation indices, buildup index, and moisture index. Again, these are all colors that give us information about the area. What we're working on at AUB now is to develop a system that take all these information together, take the different sensors and the different indices, and come up with an identification of what the problem is. So just knowing there is a problem is not enough. So previously, By just looking at this area, we know there is a problem in the yellow area, but we don't know what the problem is. What we're working on now is to identify this problem precisely in order to send the exact solution that would fit within that problem. We want to know exactly what the disease is. We want to know what the defective issue is. We want to know if there is a certain pest that's infesting the area and which of these pests is affecting the crops. Once we do, we can then send our remedy system, whether it's spraying the whole field or whether it's localized surgical spraying using a specific drone. We are developing these drones as well as developing the process to identify the issue and specify what the defect in the crops is. Now, there are some projects that we're already running within this area, which I'd like to talk to. The first one is dealing with pine processionary moth. It's a type of pest infestation that eats pine needles. Previous work by Dr. Nasim Daher looked at identifying where these nests are using an RGB, so a normal colored camera and a thermal camera, and then developed this nice drone that you can see in here. This one with a needle on board. So the drone would fly to this nest, inject it with a pesticide, and basically resolve or neutralize the issue of the pest. Now, with that kind of system, one, we are not spraying everywhere. Two, we are very surgical with our solution. And three, we are very effective because we are targeting where the nest is rather than just spraying everywhere. Another project with working with Professor Samir Mustafa is looking at reseeding, and specifically reseeding pine trees. So the first one is looking at saving the ones that haven't been destroyed yet. The second one is looking at putting new ones in wherever they have been deforested. And for that, we're working on developing a system that uses seed pods. So there is a pine seed inside this bowl with some nutrients, which will be then deployed for it to be grown. And finally, looking at emergency response. Now, fires are big issues. So two things that we're going to be looking at, medical and fires. High-rise fires create a lot of issues, especially in the UK. We had the Grenfell Tower disaster, where people were trapped because they couldn't reach stairwell cases. There were other reasons, but one of the issues is there is a fire and they cannot escape. As part of a competition in Abu Dhabi, we had to develop, this was also part of the University of Leeds, we developed a firefighting drone. The drone is not going to extinguish the whole building. What it's going to do is extinguish secondary fires to allow people to escape momentarily until, well, either they extinguish the fire or they just leave the building to burn on its own. This is an example of how the drone finds the fire. Just gonna skip slightly through it. So it finds the fire and then uses a nozzle to point the water spraying into the area. Now, that same system can be used for spraying pesticides locally and in a localized environment. And this is how the drone actually sees everything in front of it. It has a depth camera, so it knows how far it is from the obstacles. It has a colored camera to see in front of it. And we have a thermal camera in here. So everything that's white is actually hot. So we can see the fire. We can combine it with the color detection and then identify exactly where the fire is and then point the nozzle to extinguish it. Fires are not only in buildings. In the Mediterranean, we face a big issue with wildlife fire. California faces a big issue with wildlife fire. And we don't have the means in Lebanon to extinguish them effectively. What we're working on is developing fixed-wing firefighting drones. So the first level is to detect them and identify them. And the second level is to be able to carry the water into the place where they are needed. So we're developing a drone that would fly over the water bodies. In Lebanon, we have a large water body just of the coast, scoop enough water, we're looking at 300 liters per aircraft, and go and drop it where it's required. The interface with the firefighters is simply a line that they will draw for these drones to effectively fill in with water. They will go scoop up the water and drop them on this line until the full line is covered. Medical side, so just quickly, because Jason is giving me the hands up. Reaching remote locations is an issue. One solution for that we've developed is using fixed-wing UAVs, where we input the emergency kit, hand launch it, and then on the other end, we have a system that would allow us to land without a runway. We've developed a system that's similar to aircraft carriers, where the aircraft has a hook, and it hooks a cable. We have energy dissipation system, which allows it to land in a very short footprint area. So that allows us to operate in areas otherwise unreachable using a fixed-wing UAV. Obviously, there are VTOL versions, but without the VTOL, you can carry more equipment. And finally, looking at the future. These are my kids. They are involved in my work because I want them to learn what the future looks like. This is my daughter learning how to fly a drone, getting stuck in her head. So if you ever teach your kids how to fly, make sure that they do it as safely as possible. And thank you very much.
Thank you, Bilal, for a lovely talk, and great to see drones being used in non-violent ways. So many, many applications. So we have time for one quick question from the audience, if anyone has anything.
Bilal, thank you. We've been having a conversation about this, and we will continue. But I just want, there's an elephant in the room, and my specialty is elements. So we're not totally unknowing of drones, because they've been humming over our head for the past year or so, and I'm sure you're familiar with that. And so I have a question. Now you've taught us how to fly them. How can we bring them down? And that's not facetious. I mean, only a little bit, though, because there is technology that's involved in flying them.
Yeah.
And I think it would be, and of course, I'm talking out of curiosity, is there a reverse technology to unfly them?
Yes, there is. The question, do we want to develop it at AUB or not? I think that's a difficult question to answer. The answer, I think, is probably not for me. So most of my work has been in civilian applications and the civilian aerospace sector. This is why I had just a short list of images where we compared, if you want to work in aerospace, this is an aircraft, this is an aircraft, and this is an aircraft. So yes, we do have things that would create a fire, but we also have things that would extinguish the fire. My area is to extinguish the fire, and I'm pretty sure there will be other people who would create that fire.
That's cautious.
Very nicely put. Thank you, Bilal, and thank you so much for a really interesting presentation.
Just a big shout out to the guys who helped us in building these drones. We have drones that would go into confined spaces where they can fold and unfold. We have drones that can clean windows, and we have drones that can replant the world. Thank you very much.
Thank you.